Hey guys, Mrs. Traver here. We're going to finish up our 1-2 notes. In the last video, we were able to do vertex form. This is going to give us the intercept form. So here is the intercept form of a quadratic function. And notice we've got some new letters, the P and the Q. Those ones haven't showed up yet. A is the same old A we've been used to that shows us skinny or wide and whether it's up or down, opened up or down. So the P and the Q are going to be our intercepts, and I mean the x-intercepts. So we'll be able to tell our x-intercepts right from this format, and we'll have intercepts at P and at Q. Now remember, x-intercepts, that is where the height is 0. So going through the coordinate plane, it's going to hit the x-axis. That means its height is 0. So that means its y value is 0. So we're going to have x-intercepts at P0 and Q0. So at P0 and at Q0. So we'll be able to pull those two x-intercepts to graph. We also would like to graph the vertex, and the vertex formula we used before won't work this time, because remember before it was negative b over 2a for standard form, but we don't have a b to use. We just have a and p and q. So we have a different formula for h now. Our vertex x coordinate h is equal to p plus q over 2. So we can use that in order to find our h value of the vertex and then go look for our k from there. So let's run through an example that does just that. All right, this one will be y equals 1/2 x plus 3 x minus 1. All right, we can tell our x-intercepts right from the graph. So we have a point at, we want the negative p and the negative q. So the opposite of the ones you see here are going to be our points. So we have x-intercepts at negative 3, 0 and positive 1, 0. So opposite of 3 is negative 3, 0. Opposite of negative 1 is positive 1, 0. So I have both x-intercepts now, and I can go find my h as well. So let's do that. H is equal to negative p plus q. Thinking two things at once. I was thinking about the negative b over 2a one. P plus q over 2. And our p and q are right here. So negative 3 plus 1 over 2. So negative 2 over 2. So negative 1 is our h value. Our y value we can find by plugging in this h to our x's. So I have y, or k, is equal to 1/2 times the quantity, not x, but negative 1. I write it in white. We'll plug in the negative 1 plus 3. And then plugging in a negative 1 to this one as well. So we're plugging in this negative 1 to these spots from the x's. We can do some simplifying. So I have 1/2 of 2 times negative 2. 2 times negative 2 is negative 4. Half of that is negative 2. So there's my vertex, hk. All right, so I've got three things now, an x-intercept, another x-intercept, and a vertex. Let's go ahead and graph those. Give yourself a coordinate plane and plot those 3 points, and then we'll kind of cycle back. All right, so we've got those 3 points plotted at this point, and we could start our parabola from here, but it's nice to plug in a couple more points to make it more exact. So you could pick another point to the left here of your x-intercept and to the right of it. The quick way to do that is to plug it into your table. So if we do that, let me fix my graph here. If we type that into our y equals, and we go to the table function again, we'll get a bunch of values. Here's the last one that we had at negative 3, 0. Let's plot another one, maybe over at negative 5, 6. So there's another point. And symmetrically, I can be over here at 3, 6 as well. Now we've got enough to be able to plot it a little bit more nicely. It's good to at least go a little bit further out. That way you know how wide to go or how narrow to go. This one is 1/2, so it's a little bit more wide than it would be if it were an x squared. All right, let's do one more example then. Here's our last one. Our last one is going to be y equals 2 times the quantity x minus 3, x plus 5. So on these ones, again, we start off with finding our x-intercepts. And they are at positive 3, 0 and negative 5, 0. So positive, negative 3, and negative 5. All right, let's find our h as well. H is equal to p plus q, so 3 plus negative 5 over 2. 3 plus negative 5 is negative 2 over 2 is negative 1. I got a negative 1 again. That's weird. Didn't mean to do it again. Let's find our k value with that. So k is equal to 2 times the quantity negative 1 minus 3 times the quantity negative 1 plus 5. Plugging negative 1s in for our x's. So 2 times the quantity negative 4 times 4. So that looks like, let's see, 4 times 4 is 16. Divided by 2 is 8, and it's negative, so negative 8. So I've got a vertex HK at negative 1, negative 8. And I've also got 2 x-intercepts. So we've got 3 points to graph at this point. I'm going to pause my screen again, get my coordinate plane going, and then we'll catch up. All right, so coming back, we have to fix this number. We should have negative 32. That was my bad. Finishing up, though, we're going to plug in these 3 points. So I gave myself a really long graph because we're going to have to go down pretty far to get to this negative 32. So I'm going to count by 2s for all of this. So all these are going to go by 2s. So I'll have a point at negative 1, so I'll go over half, and down 16. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 32. So here's 32. So there's my vertex at negative 1, negative 32. And I've got my 2 x-intercepts. One of them is at 3, 0. I'm still going by 2s. So 3, 0 is right there. And negative 5. We should have a pretty narrow graph here. Try to still make it be slightly curved as much as you can. All right, so in these 2 pages of notes, we've done intercept form and vertex form. We will, in the next video, look at converting from those forms back to standard. So stay tuned for that.